You are listening to The Vocal Technologist. Spoken Tech for your ears.
Welcome to the show. It's a Tech Tuesday, and honestly, if you feel like the software engineering landscape has just tilted 90 degrees recently, you are not alone.
Yeah, not all.
The collection of material we're analyzing today outlines, well, nothing less than a foundational, almost epoch-making shift in what it means to be a modern developer.
It's true. The information makes it stunningly clear. We have, for the most part, solved the problem of code generation.
With AI, yeah.
And the speed of that output has just accelerated dramatically. But this doesn't mean the engineer's job got easier.
No, quite the opposite.
It means the fundamental responsibilities of the human judgment, architectural context, quality assurance have become the most expensive and therefore the most critical parts of the whole process.
Our mission today is to cut through all the excitement and, frankly, some of the worry and give you the essential playbook. We are going to figure out what skills you need to prioritize when AI is handling the easy stuff.
And how core pillars like logging, testing, and performance are having to radically evolve just to keep up.
So let's jump right in by looking at the engineer's job description itself, because that's where it all starts.
Right. The central narrative here is that AI coding agents have made code implementation an inexpensive commodity.
So writing boilerplate, crafting a function,
Yeah.
that's not the main job anymore.
Not at all. Writing tests, even a complex microservice function, is no longer the key value proposition. That means the economic value of an engineer has shifted completely upstream.
Upstream to where, though? I love this phrase the material uses. It's almost provocative. It says, we are moving toward a world where everyone is a staff engineer now.
It's a great line.
What does that truly mean for someone who's, say, mid-level today?
It means we are leaving the era where you were valued for your typing speed. Engineers are now primarily expected to focus on high-leverage skills.
So, not implementation details.
No. We are talking about architectural judgment, the ability to design systems that actually scale and last. We're talking system-level thinking across multiple domains and managing that overall complex context. Your keyboard skills just matter far less than your planning and your steering skills.
That idea of steering is so tied to what people are calling agentic coding. We're seeing developers embrace what they call vibe coding.
Right, where you just give the agent a vibe and let it run.
Exactly. You hand a tool, like a sophisticated LLM code agent, a task, and you step back and you let it run, sometimes executing multiple hands-off steps one after another.
And this is way beyond simple auto-completion. This is autonomous organization and generation.
But that shift into hands-off execution, it's raising some real psychological and operational concerns, isn't it?
It is. Developers are starting to express a genuine discomfort about the emergent, almost human-like tendencies of these LLMs. They're questioning if agent is even the right term.
Because of the autonomy.
The autonomy and the opaqueness. The complex, stateful decisions these tools are making on their behalf. It's a little unnerving.
But the real kick in the teeth here is that this incredible acceleration comes with systemic risk. I mean, if you're moving 3 times faster but breaking things almost twice as often, are you really being productive?
That's the necessary guardrail we have to install. The data we looked at shows that AI-generated code is consistently 1.7 times more variable.
1.7, wow.
And significantly more error-prone.
Yeah.
It's inherently more likely to introduce high-severity issues if you don't have robust human review and protection in place.
And the reason for that is usually context blindness, right? The agent doesn't know the history.
Exactly. The LLM agent lacks the institutional memory, the system constraints, all that undocumented legacy knowledge that a human engineer just sort of has. Acceleration without oversight is just increasing your attack surface.
So code review can't just be a diff check anymore. I love how the material put this. Since LLMs have no memory, they must rediscover everything from first principles every time.
Yes. And that means the code review process has to change its entire goal. It has to be reconfigured as a primarily a human alignment mechanism.
Human alignment, I like that.
The LLM produces the code, sure, but the humans, the team, they have to collectively maintain and update the shared vision of what the system is and what it should become.
Where the review is about making sure the team is aligned, not just checking the syntax the AI spat out.
Precisely. It's a transition from quality assurance on code to quality assurance on shared context.
That is a phenomenal transition point. If we're producing code this fast with this much variability, we have to fix our quality cycles immediately.
You have to.
Let's shift from the job description to the tools, starting with testing. We all know the pain. Bugs sneak out when coverage is below 80%, and getting to that 80%, especially for end-to-end tests, used to be a years-long, soul-crushing effort.
That bottleneck is being completely obliterated by AI-native solutions. The material describes systems that can give you high-volume, high-speed test coverage for web and mobile and get you to that critical 80% automated E2E coverage in weeks, not years.
Weeks, not years. That's a huge claim.
It is, but the goal is zero flaky tests and completely eliminating the need for slow, manual E2E validation.
And the practical evidence is pretty stunning. We saw that case study with the engineers at Drata. They adopted these tools and achieved 4 times more test cases.
And an 86% faster QA cycle time.
That isn't just an incremental improvement. That is a paradigm shift. It frees up massive amounts of senior engineering time to do that architectural work we just talked about.
That speed and clarity is critical, but it only works if we can debug what we're testing. Which brings us to logging.
Ah, yeah.
Another one of those fundamentals that's failing us in modern distributed systems. Frankly, traditional logging sucks.
It really does. It gives you almost no useful context. You're just doing string searches across petabytes of fragmented junk. It's so frustrating. So what's the fix?
It sounds like we need to inject the context back into the logs themselves.
We do. The prescribed solution is a massive shift to what are called wide events or canonical log lines. This is a deliberate architectural choice.
So instead of a single request creating 30 different log entries across 10 services.
You emit a single comprehensive log entry per request, per service.
And the benefit there, why is one wide event so much better?
Because they're explicitly rich in what the industry calls high cardinality and high dimensionality data. For you listening, that means the log line doesn't just say error occurred.
Right.
It includes the specific user ID, the session trace, the exact microservice version, the region, every custom header, everything.
So you can run powerful analytical queries.
Exactly. Like, show me all requests for this user that failed only on version 2.3 of the payment service, instead of just grepping for the word error. It elevates logging from a dump file to a searchable database.
Context is absolutely king, whether it's an LM agent, a team's memory, or a debugging log. Always.
And speaking of timeless wisdom, we have to touch on this exceptional guide on optimizing software performance. This was written by longtime Google engineering legends Jeff Dean and Sanjay Gemawat.
What's fascinating here is that their core takeaway forces us to challenge our default habits. They remind us that performance needs to be considered early.
In the design phase.
Yes, for critical code paths, before the architecture is locked down. If you just rely on post-development profiling to fix things later, you often find yourself stuck. You can't address the fundamental algorithmic bottlenecks.
It's preventative medicine versus reactive surgery. Their guide is so clear on where to focus. Algorithmic improvements, efficient memory representation,
Meaning not wasting cycles on unnecessary data structures.
reducing memory allocations, and making effective use of parallelization. Good performance is an architectural commitment, not a final, polished task.
That commitment naturally leads us into specialized areas like web development.
Indeed. And this feels like a classic vocal technologist Tech Tuesday topic. There is a brilliant new web standard coming that promises real simplification: CSS grid lanes.
This is a major structural upgrade for front-end engineers. I mean, for years, if you wanted a flexible, dynamic masonry-style layout, think Pinterest boards or complex news feeds.
You were stuck with JavaScript. Heavy, sometimes clunky JavaScript workarounds.
And now, CSS grid lanes lets you do this natively in the browser using display grid lanes.
How do they handle the complex packing order then, the thing that used to require all that computation?
They introduce a simple but powerful concept, a tolerance property. And this property lets you fine-tune exactly how tightly packed you want the items to be, giving you native control without all the overhead of client-side scripting.
That's the kind of simplification that really reduces complexity. But new standards often bring new debates, and you brought up a highly controversial opinion on an existing standard, the Shadow DOM.
I did, and the material is surprisingly strong in its critique. The consensus is that while the Shadow DOM has specific uses,
Like for iframes.
mainly for replacing hard-to-style external elements like iframes, but it is often implemented as an anti-pattern. Using it for everything complicates styling. It adds unnecessary complexity to the component lifecycle, and it should absolutely not be treated as a universal best practice.
So it introduces more friction than it solves in many common cases.
In many cases, yes.
Shifting sharply back to risk, we have to talk about security. Specifically, this embarrassingly widespread issue of exposed credentials in modern stacks, particularly with Supabase projects.
This is a massive operational failure we just keep seeing in the wild. It is shockingly easy to find these projects where a simple curl command using the anonymous public key can grant full read access to sensitive user data.
And the root cause is almost always what? A lack of row-level security?
RLS.
Almost always. It's the system that's supposed to check who is allowed to read or write specific database rows, and it's just not being configured correctly.
But isn't RLS the developer's responsibility to set up? Where's the tension there? The tension is between user responsibility and platform safety defaults. Yes, the developer is responsible for setting up RLS, but the material suggests platforms could greatly improve by adding clearer, more aggressive warnings.
Or just better defaults.
Or just defaulting the anonymous key to a highly restricted state. Preventing it from accidentally becoming a near master key for the entire dataset. It's a critical, self-inflicted risk.
That security vulnerability requires operational clarity. And that brings us right back to the idea of context we discussed earlier.
Moving from the agent's context to the team's.
Exactly.
The context window concept applies perfectly to a collective engineering team. A team has a limited, shared body of knowledge, the code, the docs, the implicit assumptions that they can hold in their collective working memory.
And if that body of knowledge gets too vast or too fragmented, the team just hits a cognitive wall.
Right. And when that collective window gets too big, the team slows down, fragments, and inevitably makes mistakes.
How do you fix that? You can't just hire more people or write more docs.
No, the material makes it clear. The solution requires the deliberate shrinking and shaping of that shared context.
So aggressively defining boundaries.
Culling unnecessary documentation, breaking down services into genuinely isolated domains, and just maintaining architectural clarity so the team can think again without having to load the entire company history into their brains every morning.
Defining boundaries for clarity. And speaking of questioning established norms, let's wrap up with a contrarian argument that genuinely shocked me when I read it. The argument against semantic versioning, or SEMVer.
I know, I thought that was untouchable.
Me too. It's gospel.
But the claim here is really pragmatic. It says SEMVer rarely helps developers prevent or even remediate breakage during a dependency upgrade.
Why? I mean, the promise is that the version numbers tell you what to expect.
The promise is, but that promise is only as good as the contract it follows.
And the lack of a contract is the problem.
Precisely. Many maintainers who claim to follow SEMVer do not have a published, explicit contract against which to evaluate their changes as truly breaking or non-breaking. They release a new major version, say it's braiding, but the end user has no clarity on what or why.
So the SEMVer promise becomes meaningless in practice.
It does. It forces developers to look for better, more transparent alternatives that provide real guarantees, not just version numbers.
Okay, let's pull all of this together. We've covered everything from demanding wide events from our logging systems to realizing that everyone needs to start thinking like a staff architect.
And that even sacred practices like SEMVer are being ruthlessly questioned.
Right. The engineering landscape is aggressively prioritizing speed, architectural clarity, and just ruthless efficiency, all fueled by agentic code.
The core tension is just unavoidable. AI offers unbelievable velocity, but that speed magnifies the consequence of poor human judgment.
So we have to deliberately slow down and shape our human context window, both individually and as a team.
To ensure that we are building the right thing and steering the agent correctly.
Yeah.
The value of the modern engineer is now entirely tied to their judgment, and their ability to ensure quality prevails over sheer velocity.
So here's where it gets really critical, something for you to mull on. We know AI can generate production-grade front ends. We know it can run destructive Git commands without the deep, nuanced understanding of what that means for a business. If we rely purely on technical checks and regex patterns to block bad or insecure agent commands, what non-technical mechanism, what part of our engineering culture and our leadership framework do we need to build into our organizations to ensure our newfound speed doesn't perpetually outpace our collective human wisdom?
Spoken Tech, for your ears.